Let's look at 6 examples of molecules to determine oxidation states of atoms. If we look at our first molecule, we have a neutral atom, therefore the overall oxidation state will be 0. Now we know from our rules that our hydrogen will have an oxidation state of +1. If we've got 3 atoms of hydrogen within that molecule, the nitrogen must be -3 to balance that oxidation state. If we look at our iron oxide, our oxygen exists as -2, therefore the iron must exist as +2 to balance that -2. Our third example, we've got a silicate, silicon tetroxide, which has an overall charge of -4. From our oxygen, each oxygen contributes -2, which gives us -8 overall. -8 plus -4 gives us +4 for the silicon. If we look at our chlorate ion, with our overall charge of -1, from our oxygen we get -2 times 3 gives us the -6. Therefore, the chlorine will be -6 plus the 1 there to give us +5. Our chromium hydroxide, our hydrogen has a +1, oxygen has a -2. So we've got -1 overall for our hydroxide, times 4 is -4, so the chromium must be +4. And finally we have calcium hydroxide. Now if we remember, hydrogen normally has a +1, but when it exists as a hydride, it's a -1, so we get 2 times -1, which is -2, therefore the calcium must be a +2.